Hello everyone. So today we'll be solving the intersection of two linked lists. So as input you are given two singly linked lists A and B, and you have to return the intersection point if the linked list intersect. For example, you are given a two linked list here. So you'll be given the head of let's say A and B. So the first linked list is like from A1 to till C3. Okay, and the second linked list is from A1 to C3. So the intersection point here is C1, so you have to return C1 as the output. Okay. Similarly, let's talk about other examples here. Let's talk about this example again. There are two linked lists here, and there is another linked list. They are intersecting at point 2 node, so output should be true. Uh, Now let's see this linked list. Since this linked list is uh, not intersecting at any point, so output should be a null here. So there's a no intersection point. Okay, so let's talk about the idea behind the solution. So the idea behind the solution is, let's say you are started with linked list A, and let's say you traverse it till the end, and now you started with a linked list B. So at any point, if you see a particular node that's already been seen by you, okay, so if it's already been seen by you, that means there is an intersection between this B and A. So whenever you see such a node, you just directly return that value. So here you can directly return C1. Or let's say after finishing with B, you don't see any common node, that means they don't intersect. So in that case, you can directly return null value. Okay. So let's directly jump to the code here. So basically, so here's the code. But to remember that particular node you have already seen or you have already visited a node, you have to somehow store that information. So here we have used set for storing that information. So let's say we are iterating over the first linked list. Okay, and basically we are adding that into the set, and we are moving into the next into that particular linked list. So once we are done with the linked list A, we now iterate over the linked list B. And if at any point we see that the set already contains this head of B, that means this head of B was a part of A as well. Okay. So if that contains, that means there is an intersection here. So you just directly return this head B. Okay. So head B is nothing but the intersection point of A and B here. Otherwise, you keep moving in the B. Okay. Till the terminates. If you don't find any solution here, that means both the linked list has been terminated. Okay, and they do not intersect. So you will directly return the null here. Okay, so that's a very simple, straightforward solution. There are other approaches as well to solve this particular question. So, like one of the approach here is, let's say you find the length of this particular linked list A. So let's say it's L1, and let's say you find the length of this linked list L2. So you find out which one is greater than. So in this case, let's say L2 is greater than L1. So let's say you find the difference. So let's say L2 minus L1 comes to be X. So what you do is, in the larger linked list, you move X step forward. So let's say you move X step forward here. So given that the difference of these two linked lists is 1, so you move in the larger linked list, you move one step. So let's say you came across this B2, and now what you do is you start iterating in the both linked lists simultaneously. So let's say initially A1 and B1. So then you check whether A1 is equals to B2. So if A1 is not equal to B2, you move both the pointers into linked list by 1. So let's say you came across this. Now A2 is equal to B3, which is not, and you finally move the pointer in A and move the pointer in B as well. So you finally come to C1. Now here you see the both pointers are pointing to the same value. So that means there is a intersection. Or if you don't find such a condition and you terminate, that means there is no such intersection. So you can return null in that case. So that's another approach here where you find the length of the linked list and then basically you move the pointers. So it does not take any extra space. Order will be order of n and time complexity will be order of n as well. Okay. So I hope you followed the question as well as solution. Do let me know if you want me to solve any particular question. That's all from my side. Till then, bye bye. Take care.